So after we folded the paper, right, so many times, we were able to kind of guess what our pattern is, right? So let's do mathematical reasoning here. So we're going to do the first difference. Do you guys remember what does it mean if my first difference is constant? What does it mean?
It's a degree of 1.
It's a degree of 1. What if my second difference is constant?
It's quadratic.
It's quadratic, right? Degree 2. Okay, so let's do that. Okay, so remember that the first difference you have to start with the bottom, take away, right? So 4 minus 2. 8 minus 4. 16 minus 8. 32 minus 16. 64 minus 32. 128 minus 64. 256 minus 128. 512 minus 256. And 1024 minus 512.
Did you get the exact same number?
I did. Good, good eye there. Okay, so my first difference is not constant, which means it's not linear, right? Okay. How about my second difference? Do the same thing. So 4 take away 2.
2.
8 take away 4.
4.
16 take away 8. 32 take away 16. 64 take away 32. 128 take away 64. 256 take away 128. 512 take away 256. What do you notice? It's not constant? No? They're the same numbers again. Okay? So it's not constant, it's not quadratic. So if it's not linear and it's not quadratic, we have to do a third test. And the third test, it's not the difference anymore. Because if we do another difference, right, it's gonna be, that means it's cubic, right? And if it's constant. But then again, if I do the third difference, 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 4. So it's gonna be, 16 minus 8 is 8. So it's gonna be another repeating pattern, right? So again, it's not cubic, okay? So what we have to do is what we call the first ratio, okay? What does the word ratio mean? Ratio. It's comparing the two with division, right? So if you divide one by the other, okay? So that means if I divide the 4 by the 2, okay? Divide the 8 by the 4, divide the 16 by the 8. But I have to go back to my original y values. So I have to go back to my y values, okay? And I have to do the ratio. So I have to divide y2 divided by y1. Okay? So y2 divided by y1, so that's 4 divided by 2. That's a 2. Right? Then if I do 8 divided by 4, that's a 2. 16 divided by 8, that's a 2. They're all gonna be 2s because it's doubling. That's right. So my ratio is constant, which is 2.
Oh.
So let's do the plot right here. So it says plot the number of layers against the number of folds on this grid. So I'm going to have the number of layers on the y-axis and the number of folds on the x-axis. Okay, I'm gonna go every 3, it's gonna be 50. I know I'm not gonna be able to fit all the points, but that's fine. So, for 0 folds, obviously, I have 1. So if you look at, if you have no folds, you have 1 face, right? So it's gonna be very close to the 0 because I'm going up by 50, okay? If I have 1 fold, that means I have 2. I know you guys can't see this. If I have 2 folds, that means I have 4. If I have 3 folds, I have 16. Can you guys divide 50 by 3 for me? 16. So if I have 3, I have 16. If I have 4 folds, how many did I have? Oh, 3, I had 8. 4, I had 16. If I had 5, I had 32. 6, I had 64.
And 7, 128.
7, I had 128.
8, 156.
What was it?
156 for 8.
128 for 7. 256 for 8. 256 is way off my bracket. Right? If I actually extend this on this side, it's gonna look like this. Okay? Where it's gonna be very close to that 0, but it's never gonna reach 0. I'm never, ever, ever gonna have 0 faces. Okay? I'm always gonna have a certain piece of face. Okay? What do we call this shape?
Half a parabola.
It's actually not half a parabola, because if it's half a parabola, it will not keep extending. Right? Because remember, half a parabola has to go back up.
Is it like exponential growth?
It is. It is. It's called an exponential growth. Okay? It's gonna keep growing, and it's gonna keep growing exponentially. Okay? That means you've seen that when we got to this point, when we got to like 8 and then 32 and then 64 and suddenly 128, 256, 512, 1,000, right? So it's growing, but it's growing very, very fast, right? I'm doing 1 fold and it jumped from 512 to 1,024.
Double.
Right? Yes. So it's jumping. It's growing much faster.
What do you call this?
Exponential. It's an exponential. In this case, it's a growth because it's growing. But it's called an exponential. So we're gonna talk about that. We're gonna write.
Yeah.
So. So describe how the number of layers changes as the number of fold increases. We've already explained that. It doubles, right? So it doubles each time. So we have an exponential growth, or grows exponentially. Fast. and second difference in the table, what do you notice? What did we notice? First and second difference?
Aren't the same.
They're not constant,
They're not constant.
but they're the same numbers as the previous y
Yeah,
values,
yeah,
right? The y
yeah.
values are repeating. So the difference are not constant. They grow just like the y value do.
And also it's repeating the same thing?
Yeah, that's why I said they grow just like the y value do. Now, let's look at the pattern with respect to the x and the y values. Okay? So if I go back here, as the xy value going up by 1, right? What's happening to the y value? It's getting doubled, right? So it's being multiplied by 2, right? Because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, right? So that means it's double. So it's being multiplied by 2. So every time I add 1 to the x, right? My y value is getting multiplied by 2, or double. Okay, so let's write that down. So if x is 1, y is 2, right? What if x is 2? Which is, if I multiply this by 2, it becomes a 4, right? What if x is 3?
6.
No? 2 times 2 times 2, that's 8. Right? So I'm multiplying the previous one by 2. Right? If x is 4,
So,
then I'm multiplying this by another 2.
so let me say the x is the number of
Okay, so-
folds.
Yes.
Okay, and alright.
So we each
And the
time
y is
we
the number
are
of folds.
multiplying with 2. I mean every number,
Yeah.
like if it's 8,
Multiply that by
we get
2.
2 8 times. It's like that.
So the 8,
If-
you're going to have to
if
multiply
x
by
is
2.
8, If x is 8, then 2 multiplied 8 times.
That's right.
Like that.
That's right.
You can do it.
Look at that. Look at that. So if I'm going to write this as an exponent, that's 2 to the power of 1, right? Because I only have 1, 2. What would this be? 2 to the power of 2. What would this be?
About 3.
What would this be?
2 plus
Okay, so x is power.
X is your power.
Cool.
Whatever your x value is, that's your power. Why is your base 2? Because it's doubling,
Double.
right? Because I'm doubling, that means my base is 2. And x is my number of folds.
Okay.
You see that? So if you fold it 10 times,
You have
Now
5
we-
over 2.
10 times then
2 to the power of
2 to the power of
10.
10.
10,
Oh,
because
okay.
you fold it 10 times.
Okay.
So it'll be 2 to the power of 10. You get that?
Good.
Yes. So I can write my function as y equals 2 to the power of x. 2 is the doubling. And x is your number of folds.
Cool.
Does it make sense? Now, we've already calculated the common ratio, right? Remember, common ratio is y2 over y1, right? And so on and so forth. What did we notice about the common ratio?
Common ratio is dividing
So when you divide it, what did we notice about the answer?
the same constant.
It's a constant, okay? And what does it equal to? What did it equal to?
Equal to.
Wasn't it 2?
Yes,
Same number.
Yeah.
it's equal to 2, which is your base. Right? So when you did if you go back to the table, right? We did the ratio, right? The ratio
Okay, because
was 2 because it's doubling, and it's the same thing as my base. Right?
So what is the thing in the bracket?
What's the thing in the bracket? It's y2 divided by y1.
Double. So now we don't have quadratic, we have ratio.
Now we have the ratio.
That's my
And that
understanding.
means it's exponential.
Okay. And degree of what?
Your degree, your exponent is the variable.
Okay.
That's why it's called exponential.
Mhm.
Okay? Because your exponent, you see where your exponent is?
Yep.
It's x. It's a variable.
Okay.
Your base is the one that's constant. And the base can be anything depending on your ratio. When you do your ratio, you can get your base. Does that make sense?
Same idea.
Same idea, but now we're doing division instead of subtraction.
Okay.
Right?
Personally, I hate quadratic, so I don't know. The ratios can be more fun.
Do you guys understand?
The always, this is the, we are talking about this drop here. The answer is coming 2 because it's doubling.
Yes.
So if other drops like these kind of exponential, so always we get the same answer?
It doesn't have to be always 2. If it's tripling, then it will be 3.
Okay.
If it's whatever, if it's like growing by 2.5, then your base is going to be 2.5. It depends on what your ratio is, right? That's going to be your base. Okay? What the ratio is, that's going to be your base. Okay? If your ratio was, let's say, 0.5, then your base is 0.5. Okay? You guys done copying? earlier, and we're going to compare all three different kinds of relations that we have seen. Okay, we're going to compare the linear, the quadratic, and the exponential. So with the linear relation, the equation is y equals mx plus b, right? If you guys don't remember, this is from grade 10 and grade 9, and if you don't remember it, it's right here. So it's y equals mx plus b. That's a linear equation, right? The exponent is 1. To prove that it's linear equation, then using a table of value, what would be constant? The first difference, right? Using a table of value, your first difference is going to be constant. That means it's linear, okay? And how will it look like? How will the graph look like? It's a straight line, right? So it will be a straight line. You're going up, going down, it's a straight line. Okay? What is your quadratic relation equation? What's the standard form of it? It's right there in front of you guys in the orange.
Oh, standard form.
Standard
Y
form.
equals ax squared plus bx plus c. Oh, we know that.
Yes, you do.
What I'm reading?
Good, you remember, see? Now, using a table of value, what would be constant? And what is the shape of the graph? Parabola. The U-shaped curve or parabola. I'm not gonna say it on the video. Now, with the exponential relation, the equation is going to be y equals, doesn't have to be 2, it can be any number, so we're going to give it the letter b because that represents a base. Okay? So y equals b to the power of x, where your exponent is your variable. Also, you would see something that might look like this, y equals a b to the power of x. So for example, if you have y equals to 102 to the power of x, right? Where only 2 is to the power of x, and then you're multiplying by 100. Okay? So that will be your a value, your base is going to be 2, and then your exponent is x. Okay? This also represents an exponential function. Okay? So the variable is the exponent, and using the table of value, which one is constant? The ratio. Right? And then it's going to look like one side is almost horizontal, while the other side either grows or decays fast.